Welcome student to Praveen Patil College of Diploma, Engineering and Technology. Our chapter is integration, chapter number 4. We have to revise the subject, that is applied mathematics. Name of faculty is Smita Shekhar Kamble. Our method is continue integration by substitution method. Last lecture we continue about this example, integration by substitution. Evaluate integration x in bracket x square minus 1 raised to 5 dx by mean of the substitution u is equal to x square minus 1. We have to consider x square minus 1. This portion u is equal to x square minus 1. We know the derivative of x square is 2x, derivative of constant is 0. That's why du is equal to 2x dx. We have to substitute the, instead of dx, we have to substitute the 1 upon 2 du. So that's why we have to put here. Instead of x square minus 1, we have to put the u raised to 5 there. And instead of x, we have to define what is it. Exactly it is x. There is the x dx is there. Be careful. Instead of x dx, we have to substitute 1 upon 2 du. And instead of x square minus 1, we have to put u. But x square minus 1 raised to 5 is there. That's why u raised to 5 du is there. We know that integration of x raised to n is x raised to n plus 1 upon n plus 1. That's why u raised to 5 plus 1, that is 6, and 5 plus 1 in denominator, 1 upon 2 remain as a constant. We have to substitute, that is resubstitution, u is equal to x square minus 1 in a final answer. That's why u is equal to x square minus 1 raised to 6, and 6 into 2, 12, and plus c is the constant. In this way, we have to substitute u and solve independently. We resolve the integration using substitution. Now next example, same pattern. 5x square is given. X cube minus 4 raised to 4 is given. Dx is there. What is u then? Yes, x cube minus 4 we have to substitute as a u. Differentiate with respect to x to both sides. Du upon dx is equal to, what is the derivative of x cube? Yes, 3x square. What is the derivative of constant? 0. That's why minus 4 derivative is 0. So we have to take the du upon dx. We have to shift these three this side. So 1 upon 3 du is equal to x square dx. So here x square and dx, we have to substitute the 1 upon 3 du. 5 constant is there. Instead of x cube minus 4, we have to put u. That's why 5 upon 3 u raised to 4 du is the integral part. We know the integration of x raised to n is x raised to n plus 1 upon n plus 1. That's why we have to take the u raised to 4 is there. So it is u raised to 4 plus 1 is 5 upon 5. So we can separate 1 upon 5. So 5 get cancelled. U raised to 5 1 upon 3 plus c is there. We have to resubstitute. The value of u is what? Yes, x cube minus 4. So we derive the final answer 1 upon 3 x cube minus 4 raised to 5 plus c. Same trick follow for x plus 1 bracket square is there. We have to resubstitute the u is equal to x plus 1. Differentiate with respect to x to both sides. Du upon dx is equal to derivative of x is 1. Derivative of constant is 0. So that's why dx is equal to du. That's why dx is equal to du, and x plus 1 is u. U square is there. What is the integration of x raised to n? Yes, x raised to n plus 1 upon n plus 1. That's why u raised to 2 integration is u raised to 2 plus 1 upon 2 plus 1, that is 3. That's why u raised to 3 upon 3 plus c is there. We have to resubstitute the value of u. U is x plus 1. So we derive the final answer is x plus 1 bracket raised to 3 upon 3 plus c. Now same trick follow for the here. We have to take the I revise the example again. U is equal to inside function x square plus 1. Du is derivative of inside 2x dx. And we have to put now the revision term. What is that? Yes, u is equal to x square plus 1. Therefore, du is equal to 2x dx. That's why 2x dx is equal to du, and 3 instead of x square plus 1 is u. U bracket square is there. So, what is the integration of x raised to n? Yes, x raised to n plus 1 upon n plus 1. That's why u raised to 2 plus 1 upon 2 plus 1. 2 plus 1 gives answer 3. So, we derive 3 in bracket u raised to 3 upon 3 plus c. 3 get cancelled. We derive the final answer u cube plus c. What is the value of u? Yes, x square plus 1 bracket raised to 3 plus c. So, we derive the final answer. Now, interesting example is different, that is trigonometry. Yes, let us check. Tan x sec square x dx. We know that the derivative of tan x is what? Sec square of x. That's why we have to put u is equal to tan x. So, du is equal to sec square x dx. That's why u remain as the same. And instead of sec square of x dx, we have to substitute du. What is the value of u? Yes, u raised to 1 is there. We know that x raised to n is x raised to n plus 1 upon n plus 1. That's why u raised to 2 upon 2 plus c. What is the value of u? Tan square x. That's why 1 upon 2 tan square x plus c. If we have to substitute the u is equal to sec x, three way we have to solve. It is independently. U is equal to sec x. What is the derivative of sec x? Yes, we know that derivative of sec x is sec x into tan x. We resubstitute u du there. That's why we have derived the same answer. Integration of u is u square upon 2 plus c. What is the value of u? Yes, it is sec. So, sec square x 1 upon 2 plus c. We know that sec square of x is 1 plus tan square x. That's why we resubstitute or derive both the way. We derive the final answer same. Now, we have to revise that example again. Better we have to take the example next. Tan x, tan 2x, tan 3x dx is there. We have to know that tan 3x is tan x plus 2x. We know that tan a plus b is tan a plus tan b upon 1 minus tan a into tan b. This is the formula from trigonometry. We have to put instead of a is x, instead of b is 2x. That's why tan x plus tan 2x upon 1 minus tan x into tan 2x. We know that tan 3x minus tan 2x is tan x tan 2x into tan 3x. How it is possible? Let us resubstitute the value of this one. So this way we have to resubstitute the value of here, and we have to take the equation 2 is in the form of combination. So tan 3x minus tan x minus tan 2x dx. What is the integration of tan 3x? Yes, it is obviously log sec x. Tan x, the integration is log sec x. That's why integration of tan 3x is log sec x into 3x, and derivative of 3x is 3. So it is in a denominator. Tan x integration is what? Again log sec x. Tan 2x integration is what? Log sec 2x upon 2. Where 2 is derived? Yes, derivative of 2x is 2. It is in a denominator. Now we have to define tan 3x integration. We know that sin 3x upon cos 3x dx. We have to substitute the cos 3x is equal to u. What is the derivative of cos 3x? Yes, we know the derivative of cos x is sin minus sin x. That's why the derivative of cos 3x is minus sin 3x into 3. How would the 3 derive? Yes, derivative of this term. So, derivative of u is du upon dx. We have to take the cross multiplication. So, simplification we have to get sin 3x dx is equal to minus du upon dx. Instead of sin 3x dx, we have to substitute minus du upon dx. 1 upon 3 is common. Take outside du upon u. What is the integration of u? Yes, that is, we have to resubstitute the value before. We know that integration of 1 upon x is log x. That's why minus 1 upon 3 ln u means log u. We resubstitute the value of u is cos 3x. So we derive the final answer minus 1 upon 3 log cos 3x plus c. If we have to substitute the inverse is there, our further simplification, if we interested, we have to shift these in a raised to minus 1. Yes, which law we have to apply? N log of m is log m raised to n. That's why minus 1 go to the cos 3x inverse. We know that a raised to minus 1 is 1 upon a. That's why we can write 1 upon cos 3x is there. So we know that 1 upon cos is sec. So we derive final answer 1 upon 3 log sec 3x plus c. If we write this way, it is also right. If we write this way, it is also right. Further simplification depend on the marks, how much marks it is asked for. So now we have to take the next example. Sin raised to 5x dx is there. So we split up the sin raised to 5. That is, we know that a raised to 5 is a. That means a 5 times. Or it is the combination of a sin x, sin square x, bracket square. We know that 2 2s are 4. 4 plus 1 is 5. We know that sin x remain as the same. We know that sin square x by fundamental identity, sin square x plus cos square x is equal to 1. That's why instead of sin square x, we have to substitute 1 minus cos square x whole bracket square. We have to now put instead of what? Cos x is equal to u. What is the derivative of cos x? Yes, minus sin x. So instead of sin x is dx is du. That's why we simplify. Minus 1 minus instead of cos x u bracket square whole bracket square. Now we have to know that the expansion of a minus b bracket square is what? A square minus 2ab plus b square. That's why we have to apply a minus b whole bracket square. Here a is 1, b is u square. So minus u raised to 4 plus 2u square minus 1. We have to simultaneously multiply the minus sign in the bracket. Now we have to take the separate integration of each term. Integration of u raised to 4 is u raised to 5 upon 5. Integration of u square is u raised to 2 plus 1 upon 2 plus 1, that is 3. Integration of 1 is u plus c. We have to resubstitute the value of u. U is what? Cos x. That's why minus cos x raised to 5 upon 5 plus 2 cos cube of x upon 3 minus cos x plus c. Same trick apply for cot raised to 4. Yes, cot raised to 4 we have to split up cot square x, cot square x. We know that fundamental identity cot square x is cosec square x minus 1. Cot square x remain as the same. We multiply cot square x into cosec square x minus cot square x dx. We have to equate the term cot square x into cosec square x minus cot square x integration separately. Cot square x into cosec square x, we have to here cot square x is what? Cosec square x minus 1. What is the integration of cosec square x? Yes, it is exactly minus cot x. What is the integration of 1? It is exactly x. We know that cot square x and cosec square x the antiderivative. So that's why we derive the cot x is there. So minus 1 upon 3 cot cube of x is the final answer. Now sin square x into cos x dx is given. U is equal to sin x. We have to substitute. Du is equal to cos x. Du is equal to cos x ds. We have to replacing sin x, u and cos x du. We have sin square x cos x dx is equal to u square du. What is the integration of x raised to n? Yes, x raised to n plus 1 upon n plus 1. That's why u raised to 2 plus 1 upon 2 plus 1. 2 plus 1 is 3. That's why u raised to 3 upon 3 plus c. What is the value of u? Yes, we know that u is equal to sin x. Resubstitute the value of u is equal to sin x. We derive sin cube of x plus c 1 upon 3. Here we have to apply integration of f dash of x into f of x. That is, we have to substitute the f of x is equal to u. Then f dash of x dx is equal to du.